Hi, this is Dave Johnson with another edition of Math Off Topics. Today I want to show you how to do 1 million factorial. If you've ever done factorial on a calculator, you know it doesn't take much to cause an overflow error. 70 factorial will cause that error. So let's get into it. Here I'm showing Stirling's formula, which is a well-known approximation for n factorial. It's not going to give you an exact answer, but for large N, this is really the only way to go. There are other versions of this formula. For example, Gosper's improvement on Stirling's formula, but those kinds of improvements work for small n. They improve the value that you get for n factorial for small n. But for large n in n factorial, Stirling's formula is fine. So how would you do this? Well, I'm going to use the logarithm, take the log of both sides. I'm going to use log base 10 because I want to write the final answer in scientific notation. And so it's going to be easier to do that with log base 10. So take the log of both sides. So log of n factorial is equal to, I'm just going to go ahead and write it, log um, n raised to the n, e to the negative n times the square root of 2 pi n. And let's go ahead and break this down. So we get n log n minus n log e plus 1/2 log 2 pi n. And it might be worth just going ahead and breaking that last log down. So, and you're going to get 1/2 log n. I'm going to add that to the n log n. So get n plus 1/2 log n minus n log e plus 1/2 log 2 pi. And if we say n is equal to 10 to the 6th, which is 1 million, then we can plug in, we get log of 10 to the 6th factorial is equal to 10 to the 6th plus 1/2 times, now log of 10 to the 6th, base 10 is just 6, minus 10 to the 6th log e plus 1/2 log 2 pi. Okay, now on the right-hand side, we can evaluate that, and there's no problem with precision if we have 10 decimal places on our scientific calculator. So let me go ahead and write that result. And I've already done that here. So we get 5,565,708.917. And just as a note, the 0.917, anything to the right of the decimal point in a logarithm is called the mantissa. And anything to the left is usually called the characteristic or the exponent. Anyway, so if I exponentiate both sides base 10, we get 10 to the 6th factorial is equal to 10 raised to the 5,565,708.917. Or I can write that as 10 to the 5,565,708 times 10 to the 0.917. That's a 917. And if we evaluate 10 to the 0.917 on a calculator, we get approximately 8.26. So our final answer is 8.26 times 10 raised to the 5,565,708. There's no way you could write that number uh, exactly. Obviously, they'd have over 5 million uh, digits. And just as a final note, so I tested the Gosper's approximation, his improvement on Stirling's formula, and found that it did not disagree. In fact, it agreed completely with Stirling's formula for that value of n. So I hope this has been helpful. If you've enjoyed this video, please like and subscribe, and I'll see you in the next video.